Here's problem 610. A 50-kilogram child riding a Ferris wheel, radius of 10 meters, travels in a vertical circle. The wheel completes one revolution every 10 seconds. What is the magnitude of the force on the child by the seat at the highest point on the circular path? Alright, so let's envision what is going on with the Ferris wheel. We're going around in a vertical circle. We have a seat at the top, and on the seat is a child. And if we were to do a free body diagram of the forces acting on the child, well, there would be weight equal to mg, and there would be a normal force of the seat on the child. That's always perpendicular to the surface and outward. So there's going to be a normal force that's going up on the child. The child's moving at constant speed in forward direction, so there's no force in the x direction. And as a result of these two forces, there is a acceleration towards the center of the circle because the child is changing direction. So there's a centripetal acceleration, and that would be our free body diagram for the child. So we would set up Newton's second law based on this free body diagram. We'd say the summation of all the forces in the y direction is equal to ma, mass times centripetal acceleration, and that is equal to the net force in the direction of acceleration. Acceleration being our positive direction. So mg is a positive force, while the normal force would be negative. It's in the opposite direction. So we're going to have mg minus the normal force. We want to find the normal force, so we're going to bring that over to the left-hand side and subtract the ma from both sides. So we'll have that the normal force is equal to mg minus ma. So this is equal to the weight, mg, minus the mass times the centripetal acceleration, v squared, over r. So we can calculate this force, but we need to find out what the velocity of this Ferris wheel is. We don't know. We're told that it completes one revolution every 10 seconds. So it goes once around on this circle every 10 seconds. So the displacement it travels then would be the circumference of this circle, 2 pi r, and does that every 10 seconds. So our velocity is going to be equal to this displacement per time. It's average velocity, but that will be the same as our instantaneous velocity because the velocity is not changing in the forward direction. So our velocity is going to equal 2 pi r over the change in time, and that's going to be 2 pi times the radius of this circle, which is 10, over 10 seconds. 10s cancel out, so the velocity is going to be 6.28, 2 pi, 6.28 meters per second. Okay, so now we can figure out the normal force. Normal force will be equal to mg minus mv squared over r. So that is going to be 50 times 9.8 minus 50 times 6.28 squared over the radius of the circle, which is 10. So that gives us 50 times 9.8 minus 50 times 6.28 squared divided by 10, 292.8 newtons, or we could say about 293 newtons. That is the normal force of the seat on the child as the child is going around this circular path. The answer is given in kilonewtons, but I would just leave it in newtons. 293 newtons is the force of the seat on the child.